Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer E-Club's Ask the Cook. We're here to talk about polymers and polymer application to help you answer the question, what do you need to know to add polymer skills to your career? You might have an opportunity from time to time where you need to copy a part geometry for a low volume purpose, some kind of engineering study, a fixture to hold something temporarily, maybe a design improvement where you're going to try several different design details and you want to have something to work with. A really interesting way to accomplish this task is something called polyurethane casting. Now we'll talk about this process for a few minutes, which is often thought of as a prototype process, but can actually be much more. Polyurethane can be made as Otto Bayer made his nearly 100 years ago by taking a diisocyanate and a polyol and reacting them together. What's been discovered over the years is that you also need a catalyst to help promote the proper molecular weight build, and you need a surfactant to make these fairly dissimilar materials, kind of think oil and water, to get them to mix. And that will give you a high quality product at the end. Now, the industry in polyurethanes, the diisocyanates, can be made in very low molecular weights, and if you do, they're volatile. So they will get in the air, and the early experimenters were exposed to these things. And what happened is it sensitized their bodies to this particular chemistry so that when they were exposed to diisocyanates in almost any form later, they had very severe allergic reactions. These can even be life-threatening. So the industry responded to this interesting chemical event here by basically doing two things. Applying very strict engineering controls to exposure to diisocyanates. Those are still practiced right up to the present day. And the other thing is that the industry developed a number of pre-polymer diisocyanates that are very high molecular weight, so they're not volatile at all. There's very little exposure, and the sensitization seems to be lung-driven. So if you don't get it into the airspace, if it's not a volatile, it tends to have very little problem. And of course that made it possible for the industry to continue with these chemistries for a very long period of time successfully. So you can just imagine, you can buy these things in a part A, which is a diisocyanate material, a high molecular weight polymer, kind of a highly viscous liquid. And then you get a B part, which would be the polyol. It can also be pre-polymerized as well to get its molecular weight up so that it's a similar viscosity to the diisocyanate. And in there'll be the catalyst and also the surfactant. So you can just take these two materials, mix them together, pour them in a mold, and get a very simple cast urethane part from it. Now, cast urethane, bowling balls are cast urethane, very rugged, very durable. You can think about the hardness of a bowling ball as being in the short D area, like most plastics and polymers. So what else can you do here? And the answer is you can make a very simple silicone mold around any object of your choosing. You know, your favorite garden gnome, some part that's fractured or broken, you can put back together and you can make a silicone mold of it, and then you can cast it back in urethane to be able to use it for later on as a fixture or so forth. Now, you see these predicaments from time to time where a group of engineers has an idea for a part they'd like to test. Why not just simply sculpt something simple that will meet the geometry needs? Make a silicone mold of that and then cast yourself off a few copies using cast urethane so that you can experiment and figure out how to make a part that is really ideal. I think you'll find polyurethane casting to be a very useful thing. Now, knowing how to use polyurethane casting to make parts that help you drive engineering development, well, that's working knowledge. Just exactly what we share with you here at this community, at Polymer E-Club, Ask the Cook. Now, don't forget to subscribe, like, turn on notifications, and even share if you appreciate the content. You can follow a link in the description to learn more about the Polymer E-Club community and how you can get involved. I'm Todd Cook for Polymer E-Club, Ask the Cook. Thanks for watching.